Alright, now let's look at the overall architecture of how these synth parameters are laid out. First, I'm going to touch on the master parameters again. Now, you can save off these master settings. For instance, you can adjust this to whatever you like. Maybe you want to change the MIDI channel to something else. Whatever you do, if you'd like to save off these master settings so that the next time you turn the power on, these parameters are recalled at what they're set at, just go ahead and hit the save button and you just save those. Every time you turn the unit on, it'll call up these values and use these values until you can edit them. And then if you want to save it for that, just go ahead and hit the save button again, but just make sure you're in the master mode when you do the save. Now let's talk about these synthesizer functions and how they're laid out. They are left to right. This is pretty much the signal flow as you'd find on your typical analog synthesizers. You start with your oscillators. Then you have your modulation of the oscillators. You've got LFOs and envelopes assigned to the oscillators. Then you go to your mixer, your filter, your LFO and envelope to modulate the filter, and finally your amplifier section. Let's break this section down first. So each one of these switches is actually 4 pages deep. So if we hit waveform, we are at oscillator 1's waveform. We press it again, we go to oscillator 2's waveform, 3 and 4, and then back around to 1. Anytime we are at oscillator 1, we can press one of these other buttons to jump to, say, the frequency of oscillator 1, frequency modulation of oscillator 1, LFO, or envelope for oscillator 1. And in any one of these, we've got 4 pages. So let's say we want to adjust envelope 3. We just hit this a couple more times to cycle around to, say, oscillator 3 up here. So these all have 4 pages. You get into the mixer, it's got 2 pages. The filter has just a single page. The LFO has a single page. The envelope over here has 2 pages, and that represents the envelope time and the envelope mod time, as we have over here. And you just press that and it alternates back and forth. And similarly, your amplifier is basically your envelope for the final VCA output. You've got your main envelope times and then your modulated envelope times if you press it again, and you just alternate between those two. So let's start with the waveform, and I'm just loading in this default new instrument patch, and I'm going to go to waveform here. We can use the encoders to adjust our waveform. You see we start out with the sine wave, triangle, sawtooth, square wave, and then we get into a pulse width. So these waveforms here, where you just see the single waveform, those are all analog modeled versions of those waveforms, and all you do is you just select the waveform. That's all there is to them. The benefit to those is those are anti-aliased, so as you play them higher in frequency, they're going to get rid of additional harmonics that could cause aliasing in the upper range. Once you get to the pulse width modulation waveform, you see some additional parameters here. Let's adjust the manual pulse width here. So we can go all the way to 1% to 99%. If we want to default that back to 50%, we can just press down on that control. So here we have our mount knob. It goes from 0 all the way up to 100. If I want to quickly get up to 100, I just press this knob. If I want to clear it out, I press it again. It's very quick, much faster than doing this, but if you want to make fine adjustments, you can do that as well. So let's turn this up. We now have LFO1 modulating the pulse width. We don't see anything happening here. Let's go look at what LFO1's doing. So here we can see the frequency is set very low. Let's turn that up, and we can see this waveform happening here. And we could change wave shapes. Stay on sine for now. So when we go back here to our waveform, we can actually see the pulse width modulation that's happening for oscillator 1. And if we adjust this mod amount down, we can see we are restricting the amount of pulse width modulation that's happening there. And we could also adjust the initial pulse width to shift that into a different range. Alright, so again, just press the width, we get out to 50%. Now we could assign envelope 1 to control that pulse width. We could use one of these sticks. Let's go ahead and try that. So we've got the x-axis of this stick controlling it. We could assign it to mod wheel. We could assign it to touch. Velocity. Key 2, which is just this range of notes. So this will be off, and this will be the max. If we go key 1, that's going to use the full range of MIDI notes, being a value of note 0 all the way up to note 127. And then we have some randomizations. So every time you press a new key, a random value is selected to apply to that pulse width modulation. Alright, so those are your basic waveforms that you're going to find in a typical analog synthesizer. Once we go past these traditional waveforms, we then get into the digital waveforms. So the Vectra provides 500 single-cycle digital waveforms that we can use. And something unique about when you're using the digital waveforms is you have not only one waveform, but you can actually have two waveforms that you're either fading between or slicing between these two waveforms. Let's turn off this modulation amount. And what that means is I'm only playing waveform 1 at this period. So we can hear and see what that waveform is as we make our adjustments there. Now, if we are in these digital waves, press this encoder, it's going to take us back down to the lowest value. If we press it again when we're at 0, 0, 0, it'll take us all the way up to the 500th wave. You can see those waveforms up there are rather complex. Now, you're probably wondering, well, how do I access this wave 2 and do anything with it? To do that, you're going to have to apply a modulation. So let's go ahead and press this button. We've turned modulation all the way up. And I'm going to select, let's say, stick Y. So now as I bring this stick to its full movement in the Y direction, I'm now selecting wave 2. Select something here. So right now we are fading. If we want to change the type to slice, we just press this encoder to alternate between those two modes. Fading is like crossfading. I'm going to go down here and select a more simple waveform for this. Now you'll notice there, like for instance, let's raise this up. Let's pick a sine wave. Somewhere there's a sine wave here. That's pretty close. So if we were to play this sound and then fade over to a sine wave, in effect what we're doing is creating a digital low-pass filter. Let's go ahead and assign, let's say, the envelope to be our modulation between these two. Now what it's going to do is, as that modulation source is at its high potential, it's going to be playing waveform 2, and as that modulation source comes down to the low potential, it'll be playing oscillator 1. Let's go to envelope 1. Let's just try it. Instead of producing a decay, I'm actually going to dial up an attack so that it fades from the low potential up to the high potential. And there, it's just jumping abruptly, so I'm going to dial up these envelope times so we don't hear that click. Now let's try some different waveforms here. could slow that down so the effect is much slower. Let's see what's happening here. Maybe select different waveforms. Alright, so that's the fade. I can show you a little bit more with the LFO. Let's go look at what our LFO is doing. We've got a sine wave set up here, and this is the rate. Now we can also change the sync of this LFO so that it always starts in a similar phase. And as we change that phase, you should hear this. You can do that for more predictable results. And this other parameter here is the start point. In order to show you that, I think I'm going to clear out these modulations real quick. Dial up a very simple waveform here. And the start point is going to shift where these two waveforms start in memory. So as we shift this, you're going to see these waveforms change. We're just going to change the harmonic content, obviously. And we can just continuously keep shifting this once we go past 256, which is the number of samples in each waveform cycle. You can see that these waveforms, 5 and 40, are now advancing to the next set of waveforms, 6 and 41. And we could fade through those, or we could select different waveforms here. Of course, at this point, we are only looking at oscillator 1, or listening to it, so that's all we're seeing. That's a great way that you can change the harmonic content of any of these 500 digital waveforms by themselves. And if you want to clear out that start point, just press that encoder switch and it takes you back to 0, meaning the waveforms play their intended full cycle. So here on Slice is different. It's a bit of a pulse width modulation type effect where you can abruptly jump from one waveform to the other. To demonstrate this, I'm going to turn the modulation all the way up. I'm going to assign stick Y, and you see what's happening there? There's oscillator 1. Now let's say we adjust this. So that's a new form of pulse width modulation between two different digital waveforms. Let's try something else. And we can also, let's say, assign our LFO to automatically do that for us. Adjust the waveform. Adjust our LFO rate. And also where our LFO is starting. So let's clear this out. Now, so if I want that phasey sound to be predictable, every time I press a new key, I can dial in the sync function to be the exact tone I want. So when it's slicing, it's creating an abrupt change in the amplitude of the waveform, or it can, which is introducing higher frequency harmonics and creates that phased pulse width type sound we're used to, which is a very unique sound, especially for the Vectra, that a lot of synthesizers can't do. We could also assign the envelope here. And in some cases you'll find that it works better to dial this amount back so you're only working within a small range of those waveforms. And I could go back to alpha. So that creates a much more complex harmonic content that normally you would only be able to achieve with 2 oscillators and slightly detuning them. The thing to keep in mind is you can do all that with 1 oscillator, and now you have 3 additional oscillators to create some very complex harmonic content. The other thing we can explore here is once we go past these digital waveforms of 0 to 500, we then have a DC level. We have a negative DC level here, we have off, and we have a positive DC level here. Now, that's kind of counterintuitive of what an oscillator is, because an oscillator needs to be oscillating, and the DC level is just a direct current. What we're doing here is let's say we're fading. So if we fade from, let's go here to off, and let's turn up our modulation amount. We can see this waveform is fading from itself to off. So we are amplitude modulating. So we're amplitude modulating that waveform there. Let's say we go to negative DC and select the slice. And here I'm going to turn off the LFO and instead use stick Y. So there is our waveform 1, and even though it's a very narrow square pulse width waveform, by slicing or at some point in the phase of that waveform, we're jumping to a negative DC level. We can then further pulse width modulate any of these digital waveforms. Let's try a different waveform here. Let's go ahead and select the full waveform. And like this. Now, it's going to sound a little bit different if you try different DC levels. Or if we select off. Let's try something like this. Here we've got a triangle. So we're fading to DC or off. Let's try a negative DC level. And we could assign, let's say, the LFO to that. Let's slow down our LFO. Try a different waveform here. Or we could assign our envelope. Or we could assign, let's say, mod wheel. Or we could assign touch. We could assign all sorts of things. So we could assign the keyboard. Here we're playing wave 1. Up here, playing mostly that DC level. There's also some other interesting things that you can use these DC levels for. Let's go ahead and select, let's say, a positive DC source. Then when we go over here to the mixer, we could say we want oscillator 1 to be controlled by the envelope. So basically we're sending oscillator 1 through a VCA that is being controlled by our envelope. What that's doing, if we're sending a DC level into a VCA and it's controlled by the envelope, it then allows that envelope to feed our filter input. So right now we hear nothing, but let's go ahead and try this. Let's clear out our envelope times. Let's set a 1 millisecond hold time for that envelope, which produces just a little trigger. Let's go to our filters and let's go into some of these that are resonant, self-resonant filters. Let's turn on key tracking as well for the filter. So that slight amount of resonance this little trigger pulse here that we see in the mixer is just enough to excite the filter to make itself resonate, which can be great for creating early analog percussion sounds. And we could also go in here to our envelope, adjust that hold time, and it's going to affect the way that pops and clicks and stuff.